right, we'll go ahead and get started. Okay, thanks you all for coming today for our, gosh, I don't know, fourth or fifth lunch and learn. Today's topic is hierarchical linear modeling. This is actually by request of Dr. Cranbuell, who had an interest, and so I'm delighted so many of you are here. I want to preface this by saying this is not a how-to, because that's a course, right? This Lunch and Learn is giving us the why we should know about this and some information that we should know. So you all know Dr. Eric Oslin and Dr. Seth Jones and Dr. Amy Ellen, so I'm going to turn it over to them and let them have the floor.
So HLM is one of those things where it's really, really simple kind of at the first blush, and then it's ridiculously complicated if you go like an inch deeper into the pool. So we were talking about like, well, how are we going to frame this and situate it? Basically, it's going to be a very, very intro to HLM and just what it does, because you know there's no in between ground of like, you know, moderately complex. It's either like here's the basics or here is 4 pages of equations that are nightmares. So we're going to give the basic overview. So can you next slide me? Thanks. Okay, so HLM is hierarchical linear modeling. It has other names, multi-level modeling, hierarchy because there are levels, multi-level because there are multiple levels, right? Most of the time in education research, we actually have nested data, right? We have levels. When we say nested, if you think literally of a bird, you know, a baby bird's in a nest, there's a nest over here and a nest over here. Same concept with HLM, is that we have students nested within classrooms. There are many ways that nesting can occur. Students within classrooms, classrooms within teachers, teachers within schools, schools within districts, right? It goes on. And usually we're not really interested in all those different nests. We're just interested in controlling for the fact that when you have nesting, some of the assumptions for regular or typical regression and ANOVA go out the window and cannot be met. So we need to correct for them. When you do have multiple nests or multiple levels, now you have variability that's being explained at different levels. So you have some of the variability that's due to the students. In fact, most of it almost always will be due to the students, right? There's just more variability among our students. But then you'll have some variability that's explained by your teachers, right? Because teachers have classrooms, and those classrooms perform differently, and good teachers may have higher scores than not as good teachers, right? And so there's variability among the teachers. And then if you get to like 3 levels, you got schools, and you have schools in Murfreesboro who do very different from one another in terms of performance. So you have variability that's explained not only by the students or at the student level, but by the schools and by the teachers and so on. Whenever you have this kind of nested data, it's called hierarchical data, okay? Next. Okay, yeah, here's an example. So you have, again, children within classrooms, that's 2 levels. You have the children and then the classrooms. Another is schools within districts, that's also 2 levels. And then you have 3 levels would be children within classrooms within teachers, which we've done studies with those, which you have. But then again, you can go by district level. So you can get into multi-levels really quickly. I think the most that programs can handle, as far as I'm aware of, is modeling for 4 levels, which I'll talk about it a little bit later, but HLM kills power so grotesquely, murders power, that if you get into 4 levels, you're talking about having, you know, needing 10,000 or more cases to actually have any chance of finding anything. So anyway, next.
Hey, Eric, would you just elaborate shortly on what you mean by kills power? Unless everybody in here may know what you mean by that.
So, okay. We have, when you do any statistical test, power is a statistical term that refers to the probability of finding something if it were there, right? So if you think about it this way, if we go to the football stadium and we stand on the goal line in one, and we have a goal line, we have two people standing on the other goal line, and we're trying to compare their height, right? And we're trying to see from 100 yards away, can we tell if there's a difference in height? And let's say those two groups represent the average height for an intervention group and a treatment group, right? So they're standing on the goal line, and they're 2 inches difference between their height. If you're 100 yards away, you're probably not going to be able to make that determination. So you have low power, we would call that. You have not a very good chance of being able to discern whether those two people are different. But now let's say you get a telescope, which is where I get the power, power comparison, and you have it that has power of 10, right? So you can make that 100 yards seem like 10 yards. You're much more likely to see something, right? And determine if there's a statistically significant difference. So that's what power is. All it is the chance of finding something if there is something there to be found. The formal term is it's the probability of rejecting the null hypothesis if the null hypothesis is false, which is, I don't know why you can't just say, hey, it's the ability to find something. Sounds much simpler, right?
Well, and the connection to HLM is that...
Okay, go ahead. No, go ahead. Well, I was going to say with the HLM, now you have, because you have nested, it's simply you have more, when you have more levels, now your power requires you to have, they're clusters, so the second level will be clusters. Power is impacted by the number of clusters you have, and then the number of individuals within clusters. And so when you get to 2 or 3 levels, I'll give you a real life example, okay? When we did the Read for Understanding grant, we had roughly 1,000 children, and we had 3 levels. We had teachers, classrooms, and students. I want to say there were 70 classrooms and 20 teachers and about 20 kids per class or something like that. We had 1,000 kids. The power was roughly 0.15, which is meaning we had a 15% chance of finding something if it was there, which is terrible. Like we had less than a coin flip, much less than a coin flip chance of finding something. So and if you had only one level with 1,000 kids, you would find anything. I mean, you would have like probably 95% or 0.95 power. Does that make sense? Was that? Okay. All right, so.
Do we want the levels? Is that what you're saying? Is that's going to help us ensure something better?
Exactly the opposite. The more levels you have, we're going to get to the pros and cons in a second. The more levels you have, the more detriment it is on your power. You always want power. Power is like, you want power because you want to be able to find something if there is something to be found. So that begs the question, well, if this kills my power, then why would I do it? Well, because it honors the nature of your data, and it represents the world that you live in, right? So you want your data to be honored and represent the world from which it comes, even though it's very costly, right? And so because it's costly, there's rules, which we'll talk about in a second, to say when is it okay to not include levels and just go with one level or vice versa, right? So here's a quick example of a 2-level set. So you have classroom 1, 2, 3, all the way up to class N, and then their students are clustered within those classrooms, right? So it's just one class has 8 students, the next one has 4, right? So there's variability among all these students, that's the student level variance. And then there's variabilities between these classrooms, which is the classroom level variability. And then this next slide is just when you get to 3 levels, right? So now you have students within classrooms, and then those classrooms within schools. So now you have variability at the student, the classroom, and the school level, right? So one of the assumptions with regular regression and ANOVA is called independency of data, which means that the scores for any one individual do not depend on another individual, right? Problem with models or data that is nested is that students from the same nest tend to look more like one another than students from another nest. And if you think about it literally in the nest in a bird way, again, assume that a nest over here has the same parents. So those babies share the same DNA, and this nest over here has different parents and they share different DNA, right? So the students or the babies within the nest are more similar than they are between the nest, right? And this is the same type of phenomenon. Typically, not always, but typically children within the same classroom perform more similar to one another than they do students in another classroom. And the way that we would maybe think about that is if we're teaching an 8 o'clock section of a class versus a 12 o'clock section of a class, the students who enroll for the 8 o'clock one are probably qualitatively different from the 12 o'clock students, right? GPA, I guarantee if you pull GPA and all kinds of stuff, there'll be differences between those two classrooms, right? So the idea is that there's dependency within a classroom, and that's a problem because one of our assumptions that needs to be met in just straight up regression in ANOVA is that your data is independent, right? But when they're in classrooms, they are dependent on their peers, they're dependent on the fact that they're getting one teacher and this person's getting another teacher. So HLM takes care of that with these interclass correlations, which looks at the variability between classrooms, right? Which really it comes down to, it tells us the amount of variance, and I think Seth's going to give an example, the amount of variance that's explained at the different levels. So we want most of our variance to be explained at the student level because we don't think about what that means for a second. If it's explained more at the student level, that means that the teachers aren't having as big an impact. And if you're doing an intervention where you've given, half your teachers are doing the intervention and the other half are not, you want the intervention to be the part that's moving and changing things, not the teachers. You want it to be a good teacher and a bad teacher that are both giving an intervention, and those students do better because of the intervention compared to a group of students that didn't get an intervention that also had a good and bad teacher, right? You want it to be due to the intervention and not teacher differences. And so one of the things we look for is how much variability is due to, in this case, 2 levels, is due to the teachers and is attributed to them. And we like to see 10% or lower of the variability at the 2nd and 3rd level. That's preferable, but it's not always the case, and there's no hard rules on this at all. I mean, I've seen ICCs, I've seen 30% of the variability being explained at the 2nd level, and it's still being published. And sometimes that's what you're interested in. But typically, people will say, well, if you have 5% of the variability being explained by the teachers, that's not a lot at all, right? 5% of variability being explained by teachers is not a lot. So there are someone that would argue, well, if you have only 5% or less being explained by the teachers, then that's an insignificant amount of variance, so you can drop that level. You can not do HLM and you can just go to the basic regression or ANOVA. You can just go straight to an analysis that does not consider levels. That is a pretty popular thought because, I mean, if it's not explaining a lot of variability, then why get punished for it in a sense, right? I think that's what the argument behind that is hey, it's not explaining that much variability. There's not a lot of going on between the teachers. So if there's less than 5, you can drop it. If you get higher than that, though, higher than 10% or so, that means some of the variability is due to differences in the teachers and not necessarily the intervention. Does that make sense? It's kind of a complicated concept. All right, next one, not working. All right, so here's a very, very simple, mathematically incorrect and wrong for all intents and purposes example, but it illustrates it. Oh, okay, so All right. Sorry, I'll stick over here. You guys following? So weird. I hope I never see this video. All right. If you think of this box as an outcome, right? It's all the variance, all the variability in the outcome. So we go give our classes an IQ test, and this represents the variability on the outcome, right? So if you add some student level predictor, right? And it explains roughly 50% of the variability, right? So now 50% of the variability is explained by some student when we just do a single level by some student factors. Then we add classroom level, a second level. Now, some of that variability that was due, that the students were explaining, it's all explained variance still, but now it's being partitioned into that which is explained by the students and that which is explained by the second level, the classrooms, right? So our variance went from explained by the student level from 50 to 30%, okay? Now, all statistical tests, F-tests, T-tests, at the end of the day, really simply look at the amount of variance you've explained over that which you have not explained, right? So if our original example is 5, we've explained 50% of the variance, right? It's 5 over 10. But then we add this teacher level, now we have 3 over 10, right? Which is a smaller level, a smaller number, right? Well, again, this is not entirely correct because we're not considering degrees of freedom and all that, but it's illustrative. The smaller the effect you have, the smaller that ratio is, the less you can explain, the lower the likelihood you are of finding something, because there's not as much to be found, frankly, right? So this is why HLM is punishing, because what used to be completely attributed to the students is now being partitioned into that which is explained by the students. The teachers, if you added another slice for the schools, this variance component would get even smaller. It'd be like 20%, let's say. And so the more levels you have, the worse it is for your powers, because the more of that explained variance is actually being, the explanatory power of it is being distributed across more levels. So again, the question comes, well, why do we do it? Well, because it honors the data, right? Next slide. All right, so this is the last slide, the practical applications. Most data we have in schools is going to be hierarchical in nature. I mean, it's most of the times we do studies where at least we have 2 conditions which are 2 different classrooms. Now, is there enough is that enough to require an HLM analysis? Actually, you probably wouldn't be able to do it with that because there'd be no variability, but HLM is a more conservative, meaning more punitive, that's another way to say it. But again, most of our behavioral science education has nested nature to it. But like all statistics, there's a disagreement on how and when to use it. I have seen an article not too long ago that said you had to have at least 50 observations at the second level before you needed HLM. So in other words, you need to do a study that had at least 50 teachers before you took leveling multi-levels into consideration. I don't agree with that because that seems like a lot. I mean, that means we would, essentially what that means, if you followed that rule, none of us would ever do HLM ever, because when's the last study you did or know anyone that did that had 50 teachers and then them having, you know, however many students? Yeah.
Were they doing it because they're appealing to the central limit theorem or something, or they're able to assume normality? Is that why this, the even number of 50 is kind of odd, but then you can see that being used as, you know, once you have it, you can assume normality. Do you have any idea why they came up with that rationale or no?
So I don't know about the central limit theorem. I do know about the rationale. Okay, so HLM is relatively new. Like I've done one what I would call an HLM analysis, where I actually reported these fixed and random effects and stuff, what was traditional HLM. Now, all the data that I ever analyze for the most part is nested, so I control for it, which is, most of the time we're not interested in teacher differences, right? We're not interested in how one teacher does different from another, because teachers are intractable. I can't change that teacher, I can't clone them, and so it's not something that we're really interested in. What we're interested in is controlling for it. We have to acknowledge that, hey, this is creating problems. If you don't acknowledge it, you are overestimating your effect. You are saying you might have something when in reality you might not. And so you need to take it into consideration. In the programs that I use, like M+, they correct for it. They use these estimation methods which take into consideration the fact that it's nested, and it controls for it and adjusts your standard errors and takes care of it that way. As far as why this number came about, 50, because HLM is relatively new and there's not been a lot of, I mean, this takes incredible computing power. Like I was gonna bring, if we had the overhead, my homework from my HLM class, I was telling Nancy it was 4 pages. It was the formula was 4 pages long, right? And I still have it. And there's like teardrops like soaked into the paper. No, but so what happens is people, well, you need to do 50, and no, you need to have 10% of the variance explained. And there's all these arguments, right? And so people run simulation studies where they say, here's our parameters. Now tell me what impact it has. And so someone ran a simulation study where they said, our results didn't start changing until we got up to 50 observations. So before that, it didn't make a big enough difference.
Thank you.
I mean, that's a good one to cite if someone called you out for it.
Yep.
But yeah.
So no one has looked at that, like across studies that have been done, because you could easily do that.
I think I'm sure there's probably, there are going to be other people that would counter that and already do. I mean, this goes back and forth for a long time, and no
We
one.
had pretty large ICCs with 10 teachers, with 10 groups.
Yeah.
So in some cases, so it really depends on what you're looking at.
Mm-hmm. At the end of the day, in my experience, what happens with any type of HLM or nested data, when you submit it, the reviewer says, I can live with this or I cannot live with this. And it's up to you to make a logical argument. But they're like, you know, P equals 0.05 is a pretty hard and fast rule for us, right? That's just the way it is. You have to hit that number, right? When it comes to this, it's the wild, wild west. Like if you can articulate it, usually I just try to write really confusing words and then hope they leave me alone.
And this is all assuming, so the example I'm going to give has questions that actually need HLM to answer the questions. So it sounds like what you're talking about is when you're writing a paper and the questions you have are all of the student level variables.
Yeah.
You're using HLM to make sure your standard errors are where they need to be and those kinds of things. Whereas the example that I'm going to just talk about shortly, the questions actually can't be answered with a one-level linear regression.
That is probably the best point to be made, that will be made today, certainly. That's a fantastic point. It does allow you to answer some questions that you have to have, like says it, you have to have a way to model multi-levels to look at that teacher variability. That's of interest to people, right? We want to see how, in the work that I've done with the intervention work, we're not worried about the teacher stuff because we can't change anything about teachers necessarily, and we want to partition out that variance and control for it and just let us isolate what happened based on the intervention. And so we control for it, and it's literally usually 1 or 2 lines in the paper that says, you know, we had nested data, here's what we did to take care of it, we corrected for it, but we're not going to discuss it because it's not important. It's not that it's not important, it's just we're not interested in it. It's like when you had covariates, right? When you say I've included 15 demographic covariates, but you don't ever report their values because you don't care about them, you just want to control for it type thing. All right. Does that make sense? Really? It probably didn't, but it's all right. It's really hard. It's really like, it really is a complicated. The bottom line is that our data is usually nested. We want to consider that and honor that, and HLM allows you to either control for that completely or answer questions about the teacher level. It's very punitive though, but you want to be conservative, because on the downside, even though it is punitive and you could say, well, I'm just going to ignore this, you also don't want to say, hey, I found an intervention that works, that in reality doesn't work, and then have that spread something that's hurting or doing no harm at best and hurting kids at worst. So, all right, Amy's up. I'll click you.
Yeah, my examples actually are ones, and that's why we were talking, like, these examples are where HLM is required to answer the questions. Or actually, these researchers are modeling that teacher variability for a purpose. Which I would be glad to send you any of these if you're interested. There are 2 literacy and then 1 policy piece, and you've probably seen the first one. That's a pretty well cited.
Yeah, if anyone's ever heard that, I think it's well cited now. What is it, like 9%? That's what they found. The teachers accounted for 9% of the overall variability in student assessment scores. That's that.
Yes. And they go through the Tennessee Star data. It's a good example of how we can use HLM. These 2 as well in literacy, where we are actually modeling what's going on in the classroom at the classroom level to say, how does that interact with what we're doing with kids, and the kids' cognitive abilities? How does that come together? And we need that at each level to be able to answer that question. So the next, and you're going to hear from Seth today. And here's one that Eric's worked on, and here's one that I've worked on using HLM. I don't know, I think we're running low on time. I'll just tell you a little bit about what we did here, and it's more along what Eric's talking about. We really wanted to control for that variability. So we had students in groups, and they were randomly assigned to these groups. And part of what HLM does is to, we were hoping that for quasi-experimental research in classrooms, now we could just handle that, because, we have a problem with saying that it's a causal effect if you're not randomly assigned because of this independence issue, right? So given that, we thought nesting would help us. HLM would take care of that problem. However, we see power is like decimated when you get a little more power than in a quasi-experiment, I mean, you could say, but not much. You really have to look at that top level of how many, for instance, at our level, we had 10 teachers, or 10 groups, that's our top level. So that's not many. The power is, not really great. But I was trained differently, I think, than Eric, and I like his perspective because it's more practical, but I was trained that you be as conservative as possible, that you partition that data out to make sure that what you're saying is actually, true, that I found a real effect, and everything, it really is due to this causal agent. So we do it, you can go to, so we do it on, for that study, go back, sorry, Eric. For this particular study, we were looking at how to develop content knowledge with struggling readers, and we found ICCs, I think we had 0.01 on the Gates-McGinnity, if you know that's a reading comprehension measure, nothing right there. But when we looked at the vocabulary piece, it was 0.19. So we had a large ICC. So we do tend to look at those, and then we just control for them ultimately in because that wasn't part of our question. Though we, I think I talk a little bit in the discussion of why that might be the case. But again, it's a made-up story because I didn't really experimentally design that to know. I'm just kind of creating a story to go with why vocabulary. And I think it may be because in the groups, the discussion that occurs in those vocabulary groups was very high. So that means they would have more dependency in those groups because of that. And if you have a talker in one group, that's what we call a clarifier talker, they're really getting everybody pepped up about the vocabulary. The other group, nobody's talking. You may see differences then in your vocabulary outcomes due to that. So these are 2 books that are suggested, I think, for HLM. This is the one that I learned from. First 4 chapters are very easy and great. After that, it's pretty much formulas.
And make that, like the first 4 chapters are the top inch
Yeah.
Eric was saying. And once you get to chapter 5, it's like,
It's great, and you're real excited about it, and then you get into actually using the software, which was the killer for me. And that you no longer have to turn that file, though, is what I've heard. In the later versions, you had to flip the file. I swear I sat there in that lab the whole time, couldn't flip the darn file. So yeah, I love it that these guys actually can do the computer piece for me. And here are the different software packages that can be used. I'm thinking about looking at Stata, because I have Stata. I think I have the version that I can run this with. But M Plus is supposedly, everybody loves M Plus. I haven't used it. Eric has used it, right? Do you have there's a second piece of M Plus that you need to actually model the ICCs, correct? Yeah. It's a little bit more expensive, but I think well worth it. Do you have the advanced version? So Eric has it. If you need ICCs modeled, he's the guy. But here are the places you can go. I like this. The University of Texas has a comparison of outputs of all of these pieces so that you can start to interpret what it means, because they call things different things. It looks different. This has, like arrows. This is. So it makes it interpreting easy. And then I also like this site here for just looking at the different packages that you can use. I have not looked at this free course, but I said a free course, that would be great. I have not actually taken this free course or looked at, but it would be a place to begin. I know statistics.com does a whole, I don't know what the cost is of that online course, but they do have that. That's it. So Seth is up.
Yeah, so I'll just give a quick example, another quick example, because for me, the HLM is actually necessary to answer some of the questions that I'm working on. So the project that I'm talking about is actually the project that I worked on when I was in graduate school, and it was a randomized trial of a middle school data and statistics curriculum, and we wrestle with what is often referred to as the unit of analysis problem, which is basically what they've been talking about this whole time. So, if you think about it, if you are over in the biology department and you're trying to understand the relationship between some new fertilizer and a plant, then you can just take a whole slew of plants and assign them to these different conditions and then do your measurements and do your study. Well, thankfully, the federal government does not allow us to amass like 1,000 children and then randomly assign them to classrooms. If we could do that, basically all of this wouldn't be necessary. But the point is that these students are nested within classrooms and schools that have huge influences on the overall variability in our outcome scores. And so for the project that I was in, our level of assignment, like the level of randomization, where we put everything in a pot and said, your control group, your treatment, your control, your treatment, was the schools. And part of that was because of the model of the intervention, that we wanted teachers to collaborate with each other, and didn't make any sense to have teachers across the hall from each other doing totally different things to us. But then it created this situation where, by design, our unit of assignment is at the school level, which, as they've been saying, makes our power go way down, because even though we had 1,000 kids, our power was much more influenced by the fact that we had 25 schools. So N of 1,000 sounds a lot more exciting than N of 25. And so those were two reasons. And then the third is that what I'm going to talk about is a study where we have a bunch of variables that describe students, so like student level, demographic, those kinds of things. But the data that I had created was about fidelity of implementation. And so fidelity scores, by definition, again, are at the classroom level. They don't make a whole lot of sense conceptually to be student. They're not student level scores. Every student in that classroom is, in the same classroom, and so gets the same fidelity scores. And so the hierarchical linear modeling allows you to have, to model variables at those different levels. So you can have variables that describe students, variables that describe teachers. So if you have studies where you have things about students, but then also like years of experience for teacher or those sorts of things at the school level, that you can have variables at those different levels. And so for me, the one example that I'll give of something that I'm still trying, we talked a little bit yesterday, I'm still trying to figure out is I'm interested in understanding, okay, so like Eric was saying, in these interventions, sometimes there's an awful lot going on due to teacher differences. And so we have evidence that the intervention itself worked, but what we want to know is to what extent was the fidelity of implementation related to how well it worked for students. And so a part of that question is, a part of the question is what's the relationship between the fidelity scores and the student post-tests, which is in the HLM. But another part of that question is if you use this new variable, so without any variables, the HLM helped me to know that something like over 25% of our variability was due to classroom or teacher and school level things. So that's hopefully you're hearing by now, that's a huge amount of our variability that's attributed to schools or teacher level differences. And real quickly, we only had like two-ish, on average, 2 teachers at each school, so that's why it's still unclear how much I can separate those two, so we've been talking about. But after using the fidelity scores as predictor variables, so we found that the fidelity scores were positively related to student outcome scores, which you would hope to find. But it also, in the model that has the fidelity scores in it, if you then take the unexplained variability that's left after what's explained by the predictor variables, at the school level, it goes from 18% of your unexplained variability without any predictor variables to like 4% of your variability. And so that seems to be suggesting that an awful lot of those between school differences, and the school and classroom issue are still complicated, and I'm not quite sure what I think about that yet. But that these fidelity measures actually account for an awful lot of variability at those levels.
Open it for questions that may not have been asked? Because I have one. As a consumer of research, help me to understand when I should be looking for HLM in the data, or like, oh, it's missing, there's something wrong with it. So help me to understand that piece if possible.
So I think we said there's that unit of analysis. So where did randomization occur? If it occurred at a different level than what the statistical analysis is done, then that's incorrect because of the reasons that we just talked about. That's the first thing that you'd look for.
Yeah, I think that's you. A lot of it comes in when they describe the participants, right? And they'll usually, if they're going to do HLM, they describe the teachers and the schools and stuff. Usually, if they don't do HLM, even though they have nested data, they just describe the students. And so I don't know if it's, if you have 300 children, you can assume that there had to have been some nesting going on, because you can't have a classroom with 300 students unless it's intro psych on campus here. But I don't know that teachers will, I don't know that there's a red flag in an article that will tell you they should have or should not have used HLM here.
Is the number of participants, that has something to do with it as well. If it's nested, and I think I understood you to say at some point that a smaller number, my interpretation anyways, that a smaller N, thinking about, the number of students, say, in particular, assuming that there's nestedness, that it wouldn't benefit you to use HLM, but I might have misinterpreted that.
Yeah, so, okay, if you think about it this way, like, if you have 3 people, you can, the mean is the average between 3 people, which is, it's not necessarily very representative of a sample, a larger population, right? And Well, let's back it up, and let's say you have one person. If you have one person, there's the mean is that person's whatever, right? There's no variability, there's whatsoever. And if you had two people, there's variability between them, but it's not really representative. And so when you have three, it's hard to say that this is a meaningful average of that generalizes to a larger population when you only have three people from that population you're trying to generalize to. So for HLM, if you're not going to have a lot of variability, and it's not going to be necessarily very accurate if you only have a few classrooms here and there. I don't know if I'm answering the question right. I don't like the way I'm answering it, but other than to say that mathematically or statistically, again, that argument is said that your estimates will not be impacted until you have 50 classrooms or whatever it is. Now, I've only seen one person say that, so there are others. I haven't read anyone that counters that and says, no, that's not true. But on the other hand, almost every HLM analysis I've ever seen didn't have 50 level 50. So people are doing it regardless of that recommendation.
And that's because of, again, it's being true to the data and what you're trying to say, what kind of causal, especially causal links, and that you're attributing to the right source. And so it's a more conservative approach to saying, yes, I've found this. So it's a conservative, it's a better approach. However, in practical circumstances, we don't always have to do it.
And I don't know that I think that for me, I don't read research looking for sample size to tell me whether there should be an HLM there. I'm asking, like Amy said, what is their unit of analysis? If they're doing if they're modeling student level variability, but their unit of analysis is school or classroom level, there's a problem there. And more generally, do I have reason to believe that in their outcome variable, that for the most part, the variability is independent of each other? Or like Eric was saying earlier, do I have reason to believe that some of these students are sort of glued together by some factor, school factor, could be neighborhood factors, there's all kinds of things that it could be, The other thing that, the other thing I was going to say is I would be asking, do they have variables do they have school level variables and teacher level variables and student level variables? But then two things to keep in mind are, number one, like both Eric and Amy have said, this stuff is called, like the language around this stuff, there's not a whole lot of nice conventions. So just because you don't see HLM in the paper doesn't necessarily mean maybe they're calling it multi-level modeling or generalized linear mixed modeling, or
talk about that really.
a lot of something we haven't talked about at all is longitudinal studies, and longitudinal studies
and growth modeling.
That's right, growth modeling. So those, some people call it growth models, and like Eric was saying, economists just they don't do any of this. They just do some correction for the standard errors, and they'll have some language around panel data or something like that. So
I think from the interpretation standpoint, though, Nancy, is that the interpretation of an effect, a treatment effect or whatever, is the exact same as it is in any other analysis. The only difference is HLM is telling you they controlled for it and said we took into consideration the fact that we had non-independence here in our data, and so we are being more conservative in acknowledging that. So that's one. And then the other is when they, like Seth, when they are interested in something that's happening at the school level, right? We're interested in what's happening between the teachers, but the way that we're the way that we're assessing the differences in teachers is by measuring the kids, right? We're seeing if the teachers are different, but we're saying are they different based on the way their students are performing. That's our ultimate outcome measure that we're collecting, but we're analyzing it at the teacher level. So if they're reporting, like he would report, we had school differences among our schools. These schools were behaving differently, or the teachers within these schools were behaving differently than the students. So it really is that unit of analysis, meaning what unit are you analyzing the kids and interested in their outcomes, Or are you interested in differences among the teachers using the kids' scores because that's who we give the assessments to, if that makes sense?
And if kids were randomly put in classrooms, then we wouldn't have as much of an issue either. If we didn't have a neighborhood issue, we're not talking that level. We're talking about within a school, just the classes within a school. If they were random, but they aren't. We know that certain teachers get certain students. Those are not random, it's not random.
Yeah.
So that's...
There's selection bias.
Right, so that's why when we randomly assign, like, okay, this class, these 3 classrooms are gonna get treatment, and these 3, and we do it even randomly, it's still, that means that we've done that at the teacher level, but there are differences among those students, the way that they've been placed, likely, or from what the teacher does that impacts those groups that we have to take into account. And we have to attribute, if we're looking at an intervention, we want to only say it's only the factors associated with this intervention that make the difference. We can only do that if they were randomly assigned, design-wise. So since they're not, HLM helps us in that case because we can model those differences. But really, at the end of the day, we need just lots of classrooms. So you have to choose one. Random assignment, trying to get people to do random assignment, which we typically do, and then we tend to be ultra conservative, so we randomly assign to treatment and control, usually pulling kids out of class to work with them one-on-one, and then we do it within, we stratify based, we have so many treatment and control in each school, but even then we do HLM on top of that, so it's like ultra conservative. So it depends on which research groups you work with. IES really expects you to be, when you write up large scale intervention grants, you have to be ultra conservative to get those funds. So your power is based usually on a multi-level modeling piece. Would you say?
Yeah, I mean,
And
you
some
always have
projects you've
to
worked on too.
report power.
Well, and the only other thing I'll say is, Eric said this earlier, but it influences the consumer question, that these techniques have only been developed in the last, 15 years? 20? Yeah, so if
I
you're...
went back and was looking at Rodenbush's early stuff, and it was 20.
But that was only
30.
him talking
It was
about
only
it.
him,
It's
right.
only
The
been
book,
widely
right,
used
about
for 10 or
2000
15
is where,
years.
yeah, it's about 2000.
And so if you're reading
became real
research
popular.
that's older than about 10 years old, if you're reading research older than 20 years old, almost certainly it's not being done. If it's older than 10 years old, it's like maybe. So at that point, you just got to ask, I think we have to ask ourselves as a field, well, what do we, you don't necessarily, I'm not of the camp that you just throw away all that stuff and we didn't learn anything from it, but we didn't have the techniques to model our data well back then.
And on the flip side, what Eric's saying, we don't look at power enough in education. So we have, because we have such small studies and small samples and not enough funding to do these. You could never find out anything if we all had to use, the perfect analysis plan and design. So it's a give and take. It's not a question it's not a black or white answer, unfortunately.
That's my question, what would that perfect world HLM project look like? Would it take 200 teachers and 10,000 students? Like, what would that, just in a perfect world, I got all the money I need, I got all the resources, what would make that work?
And even under those conditions, I think.
Well, and it depends on how big the effect is you're thinking is going to happen. So things that affect power are the change you think is going to happen. Of course, smaller changes are harder to find than humongous changes. The amount of people in your study, the amount of variability, those are the 3 things, right? The amount of variability in your outcome measure that's there to be explained anyways. And so for this study, and whenever we wrote the grant, we did the power analysis, and we put like a 0.3 effect size is what we used, which is a big. That's like being pretty confident about your intervention. That's a huge thing that you think is going to happen.
Was it in math or?
It was in middle school data and statistics, and these are things that are almost never taught in middle schools
then you
at all.
probably could have gotten a
So we were
0.5.
hoping for that.
Yeah.
So anyway,
If you
0.3
don't
is
teach it, there's a bigger chance to get a difference between
Yeah.
the treatment control.
Yeah,
So
'cause it's not being
that's
taught.
why, whereas our stuff is taught, so it's really difficult for us now to get those
Yeah.
kinds of effects.
So we were expecting a big difference, and we still needed 40 classrooms in order to have an 80% chance of finding that difference. So even 80% chance of finding it, for
that's the
IES
bar,
grants,
that's
it's
the
kind of the
going,
bar.
yeah,
It needs to be at least an 80% chance of finding it. But even then, you got a 20% chance of not finding this huge difference.
And
That you hope will be
how
there.
many students did you need for that?
It was a little over 1,000.
And money-wise, what did that cost to do? And
Yeah,
this is-
it was. I mean, it was one of these big IES efficacy studies
That
that were
required
like
how-
$5 million.
Yeah, 5 million is what we,
$1
typically the ones that we work on are 5 million that have this, that actually have the design, you know, the way you're supposed to do it and the power that you need. Yeah, same thing. So it's like, how many people in education can do that? So we
Yeah.
have a big issue when we think about this stuff.
My second question was, so at a certain point, somebody was doing studies, and they said, you know what, we're not looking at these different groups. That's what I'm always interested in, is how does someone find those things? And they decide, oh, you know what, we need a whole nother modeling avenue. Is that something is that kind of how it went down?
Right, and there was
Yeah.
a person before that.
Tony
they
Brack
modeled-
and
yeah.
Stephen Rautenbush.
Right, yeah, they were the ones that said, okay, we're not taking this into account.
Because if you think about educational research, historically, until about the 70s, most quantitative research was in ed psych worlds, which were laboratory studies. So you bring students in, and in that kind of design, you can assign, you need, what, 40 kids. And you say 20 here, 20 there, we're going to bring them in, we're going to do the interviews, that's our data, that's our study. And then we started to learn as a field, oh, well, we're learning a good bit in the laboratories, but actually when we go into classrooms, what we're learning in the laboratories isn't actually helping us understand what's going on in this weird thing over in the school. We better start doing our research in the school. And so it's like, so that was like in the 80s that started happening, and then in the, mid-90s or whatever is whenever these folks really started saying, hang on, now that we're in schools, we're not modeling our data right. And I think economists maybe have been doing this for longer than us.
That's cool.
And I think the point was, you know, if you have dependency among your students, right? If the students, if my score is dependent, or it's not dependent, but related to SES score because we have the same teacher, then it makes it harder to say.
Because you guys talk a lot.
Or because we talk a lot,
Instructions, you know,
right.
and that's,
Then it makes it harder to say that it's an intervention effect versus the fact that we're with a good teacher, right?
that those two particular people are together.
Right, or whatever's causing our nestedness, our dependency. So I think people realize, like, you know, when you have students that, if you really want to isolate your effect, you really want to isolate what is the causal component here, you have to take everything that may be influencing your outcomes into considerations. And because students are taught things and they're in classrooms together, some of the differences in their scores may have nothing to do with the intervention, and it may just be because they're with their buddies or they're with a great teacher or something. It's fine because we can acknowledge that and control for it to isolate the real effect of a treatment. That's the whole point, is to acknowledge, say, yeah, look, we know that there's variability between these people and it's not due to the intervention, so let's just take it into consideration, take it out of the picture so that we can isolate our effects.
So above and beyond that, do we see an effect? If we remove that, is there something left that we can say, yeah, there is an impact?
It's really about, how do you really know that this is what? How do you know it's this and not that?
That's exactly what
That's
it is.
exactly it.
How close to the truth?
Yeah, and it's and if you think about how close to the truth is, that's a great statement. How close to the truth is how close your data analysis is to the world that it comes from. And so if we're analyzing data that comes from nested classrooms, our analysis has to map onto that. We can't say, okay, we've got teachers and students over here, and then say, okay, I'm only looking at student outcomes with my analysis. That doesn't honor the fact that they're coming, right? So that's not a real world, that's not mapping on a real world to a real world analysis. So yeah, everything about doing an HLM analysis is more conservative, more punitive, and you're much less likely to find something works.
But it's closer, but when you do find it, you can say, you know what, this is probably real.
Which would make you say, why would anyone do this? Well, because it's true. I mean, true is a
Well, but the implications are tremendous. If you think about, the implications for funding, for policy.
Oh, it would be fascinating to go back and look at old efficacy studies of any intervention 20 years ago that didn't use.
And they haven't. So some of the data that, one of the studies here that they do, or one of the authors here goes back and they do that quite a bit, especially with the Tennessee Star, because it's the best designed study in education, and on classroom sizes and its impact on student outcomes. So because of that, it's been studied by a number of people using different techniques and newer techniques, which is interesting.
The good thing is that there's always more difference within students than there are like across teachers. There are teacher effects, but it's not like a phenomenal teacher can move an entire classroom to stand.
We wish
That's
so.
the good news
opposite.
analytically.
Right,
The bad news
But on our
educationally.
side, right, how can we develop teachers and make these teachers more like those teachers and model that? Like, that's what we're trying to get at for teacher improvement. But from an intervention standpoint, we want all that to go away so we can just talk about what is the, does this procedure work? So it is a different kind of perspective.
Yeah, I think it's just, within the distribution of, well, that would
It's
get
like-
really complicated really quick. There's just more variability within the students usually than there are between teachers, which is a good thing. That helps us. So thankfully, that's like just a protective factor that there's always more variability within. I mean, you have students in your classroom, some that do really poorly, most do around the middle, and then some that do really well, right? Not normal distribution.
Yeah, I think of the old transparencies from our overheads, and teachers would have one, and then they'd layer it, and you'd see the next, and then and that's what I think I see here is layering, where it'd be like a map of something, and you put the next little strip of plastic on it, and you see that other things now are grafted onto it.
Yeah.
So without those, you said mapping, but it's almost overlays
Yeah.
that guarantee that we're trying to get to something real.
And again, I'll go back for people who are interested in teacher factors. All of those are at a different level if you're using student assessment scores as your outcome variables.
It's the only way really to do this.
So you have to do
Yeah,
that.
this
You
is the
have
only
to
way to
model
really
it.
do that one.
I think that's a good point, and I keep, failing to remember that, because I'm usually never interested in the teacher differences. I don't care, because I can't change teachers, and I can't bring
You
it.
can't change teachers.
No, but I mean, like, I can't. No, like, I can't. No, what I mean by that is that you want an intervention that
When you're doing intervention work.
you want an intervention
Yes.
that any person can pull off the shelf and do it with fidelity and have it work, is what I'm saying, right? So I want the power to be in the intervention. And I don't care about school different as much. I just want a control for it, take it out of the picture. His questions are, I do very much want to know what is happening at these different levels. And so the only way to answer, both, his is, that's the only way to answer that question. Mine is, this is the right way to answer, or the honorable way to answer this question. I don't know, it's not right or wrong, it's the appropriate way to answer this
It is the
question.
right way to
Yeah,
answer.
I hate to be emphatic,
yes,
but this is the right way to do it.
Yeah.
This is the only way to do it. So it depends on what you're looking at. Oh, sorry.
No, that's good, thank you. I have sent you all a link to the survey that just gives me feedback about, this session. And let's thank our,